video we are going to discuss about the classification of discrete time system. In this video we are going to discuss what is system, what is discrete time system, what are the classifications of discrete time systems. So first of all, what is system? It is a physical device that performs an operation on an input signal and produces another signal as output. So system, it will take a input as input signal and it produces the another signal. So here we are going to take system. System may have one or more inputs and one or more outputs. So it is defined as a system is defined a set of elements or a functional blocks. These are the set of elements or functional blocks which are connected together to produce an output in response to an input signal. So here the inputs are called for a system are excitation and output of the system is called response. Okay, so here the system is defined as it is a set of elements or functional blocks which are connected together to produce an output in response to the input signal. So systems are two types: analog continuous time system as well as discrete time system. Here digital signal processing deals with discrete signals. So here we are going to discuss about the discrete time system and classifications of discrete time system. Discrete time system. A discrete time system is a device or an algorithm that operates on a discrete input signal x of n according to some well-defined rules to produce another discrete time signal y of n called the output signal. So here we are taking a discrete time system. It is a device or an algorithm. It is a device or an algorithm that operates on discrete inputs. Here we are going to give the only discrete inputs and we are going to get the discrete outputs for the discrete time system. So here x of n is the input. I am taking here y of n as output. So here y of n will be written as transformation of x of n or h of x of n. So this x of n is going to input will be converted to y of n signal. So discrete time systems are classified into static and dynamic system, causal and non-causal system, linear, non-linear system, time variant and time invariant systems, FIR and IARE systems, stable and unstable systems. First we are going to discuss about the static and dynamic systems. Here what is static system? So a discrete time system is called static or memoryless if its output at any instant of time depends on only present input samples. So output at any instant n depends on the input samples at the same time, but not on the past or future samples of the input. So here static systems are called as memoryless systems. Static systems are called as memoryless systems. That y of n, the output at the particular time instant n depends on the input sample at the same time instant. It will not depend on the past or future input samples. That system is called static system. And what is dynamic system? Here if the output of the system depends on the past input and future inputs at the any instant of the time, the system is stated to be dynamic system. These systems are memory systems also. We can call these as the memory systems. So here for example, I am taking y of n is equal 2 into x of n. So here the present output y of n depends on only present input value of x of n. The present output at n depends on the input samples at the same time x of n. So here this is called as static system or memory less system. It is not depending on the past or future samples. For example, I am taking another example. Y of n is equal x of n plus x square of n. Y of n is equal here. The output depends on only present inputs values only. X of n is also present input and x square of n also present input. So this is called a static system. Let us take another example. Y of n is equal x of n minus 1 plus 2 into 2n minus 1. See here, this output y of n at the time instant n depends on the past input values. N minus 1 is the past input values and 2n minus 1 is also past input values. So this is called as a dynamic system because the output depends on the past input values. If we take another example, y of n is equal sigma k is equal 0 to infinity x of n minus k. If we substitute n is equal 0, you will get this is y of n is equal x of n minus 1, x of n minus 2 up to x of infinity value. So here the output depends on the past input values. These two, the output depends on the past input values. So this system is called the dynamic system with infinite memory or finite memory, because this signal y of n, for this one y of n, if you substitute k values, it will be, if you substitute k is equal 0 in this, x of n plus if you substitute k is equal 1, x of n minus 1 plus x of n minus 2, this signal will be up to infinity. Okay, so this system is called the dynamic system with infinite memory. If we consider this one, y of n is equal sigma k is equal 0 to n x of n minus 1. This will become y of n. Substitute k is equal 0 to n. So x of n plus x of n minus 1 plus x of n minus 2. K is equal to n means x of 0. So it has a finite number of input samples for the y of n. So it is a dynamic system because this present output depends on the past input values. So this system is called the dynamic system with finite memory. For example, I am taking another example. Y of n is equal x square of n, whether it is a static or dynamic. Further, substitute n is equal 0, n is equal 1, n is equal 2 values. For n is equal 0, y of 0 will be x square of 0, n is equal 1, y of 1 is equal x square of 1. For n is equal to, it will be y of 2 is equal x square of 2. So here the present input sample for n is equal 0, the output depends on the same instant of the time near the input. So it is not depending on the past or future values. So this system is called static system or memoryless system. Let us consider another example. Y of n is equal x of n minus 1 plus x of n plus 1. Here also substitute n is equal 0. For y of 0 we are going to get, substitute n is equal 0 here, x of 0 minus 1 minus 1 plus x of 0 plus 1, 1. For n is equal 1, y of 1 is equal 1 minus 1, it is 0, plus x of 1 plus 1, it is 2. For n is equal to, y of 2 is equal x of 2 minus 1, it is 1, plus x of 2 plus 1, it is 3. So like that, if you substitute n value, see here the y of 0, the nth sample, the 0th sample of the output will depend on the past value as well as future samples of the input. Past and future input samples. See, if you consider y of 1, it is also the depend on the past as well as future values of the input samples. So y of 1 should depend on only present input samples for a static system, but it is depending on the past as well as future samples of the input. So it is called this system is called the dynamic system. So these are the examples for static and dynamic system. Static system, the output at particular instant of time depends on only present input of the at the same instant of time. It will not depend on past or future samples of the input value. Okay, this is called a memory less system. Whereas in dynamic system, the output at the particular instant of time depends on the past as well as future input samples. Then this system is called a dynamic system. Then what is causal and non-causal systems? Causal system. A system is said to be causal if the output of the system at any instant n depends only on the present as well as past input values only. It will not depend on the future input samples. So here the causal system, it will depend on the present and past input samples values, and it will not depend on the future inputs. Then the system is called the causal system. Causal systems are real-time systems. They are physically reliable. The impulse response of the causal system is 0. We should remember this. The impulse response of the causal system is 0 for n less than 0. Since del of n exists only at n is equal to 0, so h of n is equal to 0 for n less than 0. So the examples for causal system, see here I am taking y of n is equal to n into x of n. So the present output depends on the present input value only at the same instant of the input. So this is called causal system. Another example, y of n is equal to x of n minus 2 plus x of n minus 1 plus x of n. See here, the present output depends on the past input values as well as present. It is not depending on the future value. So this system is called the causal system. This system is called the causal system. What is non-causal system? A system is said to be causal if the output of the system at any instant n depends on the future inputs values. Then the system is called non-causal system. Future inputs as well as past inputs also. See here, x of y of n is equal to x of 2n. See here, substitute here, n is equal to 0. For this example, y of n is equal to x of 2n. So substitute n is equal to 0, you will get y of 0 is equal to x of 0. For n is equal to 1, y of 1 is equal to x of 2 into 1, 2. For n is equal to y of 2 is equal to x of 2 into 2, 4. So the present output values, the present outputs values are depending on the future input samples at the instant n. So here y of n depends on the sample at the n is equal to of x of 2. So it is depending on the future input value. So this is called as a non-causal system. Then what is linear and non-linear systems? So linear and non-linear system is dependent. First of all, we are going to discuss what is linear system. Here a system satisfies the principle of superposition is said to be linear system. So for linear system, they should satisfy the principle of superposition theorem. So and the system which does not obey the principle of superposition is called a non-linear system. So what is superposition principle? Superposition principle states that the response of the system to a weighted sum of signals, should be equal to the corresponding weighted sum of the outputs of the system is to each of the individual input signals, are known as superposition principle. So for example, I am taking here two individual signals x1 of n and x2 of n. I am taking scaling factors for these two. So after combining these two input samples, I am going to get a1 x1 of n plus a2 x2 of n. Okay, so then this is going to given as input to the system. I am going to get y of n is transform of a1 x1 of n plus a to x2 of n. Another x1 of n is given to the one system, individual systems. So here I am going to get a1 y1 of n and x2 of n also given to the another system. Here I am getting a2 y2 of n. These are the transform of a1 x1 of n. This is transform of a2 x2 of n. These two weighted sum will be y of n will be transform of a1 x1 of n plus transform of a2 x2 of n. These two we should get the same results. Then the system is called the linear system. It should satisfy the superposition theorem that the weighted sum signals should be weighted sum signals should be equal to the weighted sum of the outputs a1 y1 of n plus a2 y2 of n. Here this is a1 y1 of n plus a2 y2 of n. So these two should be the equal. Then this is a linear system. It should satisfy the superposition principle. So for linear system, it should satisfy the condition transform of a1 x1 of n plus a2 x2 of n, total weighted sum of inputs, should be equal to the individual responses of the output a1 y1 of n plus a2 y2 of n. So here for the superposition theorem, it should satisfy the two properties, additivity property as well as homogeneity property. It should satisfy the two properties. The two properties are here. Transform of x1 of n plus x2 of n is equal to the individual transform sum of the individual transform. So transform of x1 of n plus transform of x2 of n, that is y1 of n plus y2 of n. So this is the additivity property. Homogeneity properties are scaling properties called as transform of a of x1 of n is equal a into the scaling factor a into transform of x of n. This is transform of x of n. So x1 of n is given to one system. We are going to get the response is y of n, and x2 of n is one input signal is given to the system. We are going to get the response y2 of n. So here scaling properties transform of a into x of n is equal a into transform of x of n. This transform of x of n is y of n, output response. So a of y of n, that is homogeneity property. So here a is the arbitrary constant. So for superposition theorem, it should satisfy the additivity property as well as homogeneity property. So the final condition for linear system is transform of a of x1 of n plus b of x1 of 2 is equal to a into transform of x1 of n plus b into transform of x2 of n. This we can write as y1 of n. This we can write as y2 of n. So this will become a y1 of n plus b y2 of n, individual responses of the input signal. So let us take one example. Then we will understand how to find out the linear and non-linear system. So determine if the system described with the following input-output equations are linear or non-linear. So I am taking the example y of n is equal to n into x of n. We should know whether it is we should determine whether it is a linear system or non-linear system. So for that, we should remember here y1 of n and individual responses of the outputs. y1 of n is transform of x1 of n and y2 of n is transform of x2 of n. That is n into x1 of n plus n into x2 of n. Okay, whatever we have, y1 of n is equal n into x of n. So for y1 of n, we are going to get the n into x1 of n. For y2 of n, we are going to get the n into x2 of n. Okay. So what we have to find out here, we should satisfy the superposition theorem for linear system. So here the weighted sum of the output is called a1 into transform of x1 of n plus A2 into transform of x2 of n. So what is the transform of x1 of n here? N into x1 of n plus n into x2 of n. Take this as equation 1. And the output is due to weighted sum of the inputs. So here we have to take the weighted sum of the inputs as a1 x1 of n plus a2 x2 of n. So, and we have to give this to the system. We are going to get the transform of weighted sum of the inputs is here. Substitute here wherever the n is there, x1 of n is there, we have to substitute this value. Wherever the x of n is there in the problem, we have to substitute this weighted sum in place of x of n. So here we have y of n is equal n into x of n. Substitute the weighted sum here in place of x of n. So we are going to get a1 x1 of n plus a2 x2 of n. Then it is a1 x1 of n plus n into a2 x2 of n. This is equation 2. If both equation 1 and 2 are equal, then the system is said to be linear. So here in this problem, we have equation 1 and 2 both are same. So this system is called a linear system. Take another example. Y of n is equal x of x square of n into x square of n. Whether it is a linear or non-linear, we will discuss this one. Y of n is equal n into x square of n. So individual output responses are y1 of n is called n into wherever x is there, x1 square of n. Y2 of n is n into x2 square of n. So weighted sum of individual outputs are a1 y1 of n plus a2 y2 of n is a1 n x square of n x1 square of n plus a2 n x2 square of n. This is first equation. And another one, we have to take the weighted sum of inputs. Weighted sum of inputs. So transform of a1 x1 of n plus a2 x2 of n. So wherever x of n in the problem, there we should substitute this weighted sum. So we have x square n into x square of n. So n into replace here this weighted sum in replace with the x of n. So here a1 x1 of n plus a2 x2 of n whole square. Because we have here x square of n. So this x replace x of n by weighted sum. Here we are going to get a1 square x1 square of n plus a2 square x2 square of n plus 2a1 a2 x1 of n into x2 of n. This is equation 2. Here equation 1 is not equal to equation 2. If we see the equation 1 and equation 2, these two are not equal. So it is a non-linear system. It is a non-linear system because it is not satisfying the superposition principle. Okay. Time, another one is time variant and time invariant system. Here time variant and time invariant system. A system is said to be time invariant or shift invariant if the characteristics of the system do not change with time. The characteristics of the system do not change with the time. That is, if the excitation is delayed by the k units, then the response of the system also delayed by the k units. That is, if the input is delayed by the k units, and then the output should also delayed by the same k units. Otherwise the system is, if it is satisfied this one, then it is time variant system. Otherwise it is a time invariant system. For example, I am taking a system. Here this is x of n. This is response we are going to get for x of n is y of n. For example, I am taking this 0, 1, 2, 3, 3, 2, 3, 2, 1, 1. Output I am getting some samples response I am getting. This is my response for the output. For example, I am delaying this input by the k samples. For example, I am delaying my input by the 2 samples. It is going to shift to the left side by the 2 units. So 0, 1, 2, 3, 4, 5. So it is the input signal is shifted to the left side by the 2 units. It is a delayed signal. So it is starting from here. 3, 2, 1, 1. This input is given to the system. Then y of n minus 2. That is nothing but, if it is a time invariant system, then the characteristics of the output should not change. If the input is delayed by some units, the output also delayed by the same time units, and the characteristics of the response should not be changed. So it is the output response also delayed by the same time units. 6, 5, 4, 3. So if input is shifted by the 2 units to the left side, then output also shifted to the 2 times to the left side. The characteristics of the output should not change. Only time shifting will be there in the output. So the system is time variant system. Otherwise it is a time invariant system. Otherwise it is a time variant system. See here, I am taking x of n. I am taking x of n. I am shifting the input delayed by the k units. So I am going to get x of n minus k. Then the input is given to the system. I am going to get the response as y of n comma k. Okay. This is the delayed response of the input signal. And again I am taking x of n as input. I am giving here, directly I am giving to the system. I am going to get the response is y of n. Then I am delaying this output response by k units. So then I am going to get the y of n minus k. This is delayed output response. Delayed output response by k units. If these two are equal, then it is a time invariant system. Y of n comma k is equal to y of n minus k. Then it is a time invariant system. If it is both are not equal, we can call this as time invariant or shift invariant also. If it both are not equal, this is time variant signal. Okay, so first for that, if we want to know whether we are getting that it is a time variant or invariant system, we have 2 steps. First of all, we have to delay the input sequence by k samples and find out the response. That is y of n comma k. First we have to delay the input signal by the k samples, delayed version of the input by the k units, x of n minus k we are going to get. Then we are going to give the system. We are going to get the response y of n comma k is the transform of x of n minus k. And second step, delay the output sequence by k units. Whatever the output we are getting, that delay by the k units. If both are equal, then the system is time invariant. Otherwise it is a time variant system. So let us see some problems. Then we will understand detail about time variant and time invariant system. Here, y of n is equal to x of n plus x of n. I am taking this signal in a problem. Y of n is equal to x of n plus x of n minus 1. So we have 2 steps for to know that whether it is a time variant or time invariant system. So for that, first step 1, the input is delayed by the k units. That we are going to get y of n comma k. That is transform of x of input is x of n. It is delayed by the k units. So x of n minus k. Okay. So just whatever the input signal is there, x of n. So the x of n is delayed by the k units, that we can write as x of n minus k. And second term x of n minus k. So this is also delayed by the 2 units, x of n minus 1 minus k. X of n minus k, x of n minus k minus 1. This is first step. And second step is the output should be delayed by the k units. Here output is delayed by k units represented by y of n minus k. So y of n minus k is x of, here wherever the n is there, replace by n minus k. Wherever the n is there, replace n by n minus k. So x of n minus k plus x of n minus k minus 1. This is second equation. So both are equal. So it is a time invariant system. Y of n comma k and y of n minus k. The input is delayed by the k units and then the response is given to the system. That is first one. And the output is delayed by the k units. If both are equal, then the system is time invariant system. Let us take another example. Y of n is equal to x of minus n. So y of n is equal x of minus n. See here, I am shifting the input by k units, x of n minus k. So this will be just whatever the input is there, x of minus n will be shifted by the k units. So minus k, minus n minus k. Where output is delayed by the k unit, just replace n by n minus k. Wherever output is shifted by the k units, replace n by n minus k. That is x of minus of n minus k. There is a difference between these two. Just input is delayed by k units means just we are delaying the input by k units. Just add minus k. Here for output delaying by k units, y of n minus k, replace n by n minus k. So here minus of n minus k, this is minus n plus k. This is equation 2, this is equation 1. Both are not equal. Y of n comma k is not equal to y of n minus k. So it is time variant system. Let us take another example. Y of n is equal x of n by 2. Directly I am doing the steps. Here step 1. Input is delayed by the k units. Here y of n comma k, that is x of n minus k, transform of x of n minus k. Just input is there, x of n by 2 is delayed by the k units. I am adding minus k here. Whereas in step 2, the output is delayed by the k units, that is y of n minus k. Here just replace here n by n minus k. Here n minus k divided by 2. So this is equation 1, this is equation 2. Both are not equal here. So y of n comma is not equal to y of n minus k. It is a time or shift invariant system. It is a time variant system because y of n comma k is not equal to y of n minus k. The input delayed by k units. Here output is delayed by the k units. Okay, these are the time variant and time invariant system. Here linear time invariant system is nothing but we will discuss in the next class in detail about linear time invariant system. If it linear time invariant system, it should satisfy the linearity superposition theorem as well as time invariant system properties. Then that system is called linear time invariant system. It is classified into according to the type of impulse response as FIR system as well as IR system. Here FIR system is nothing but if the impulse response of the system is finite duration, then the system is called FIR system. So here the output depends on present input values. Okay. Here for an example of FIR system, h of n is called 1, 2, 3, for n is called minus 1, 2 and 1, 0. So here the impulse response in the finite duration. So it is in the finite duration, then the system is called FIR system. If impulse response in the infinite duration, then the system is called the IARE system. So a power u n u of n. So it is up to the response of is infinity duration. So then the system is called the IARE system. stable and unstable system. The system is said to be only when the output is stable, when the output is bounded for the bounded input. That condition is called BBO, bounded input we are giving, we should get the response also, bounded output. So then the system is called a stable system. For the bounded input, if the output is unbounded, then the system is called the unstable system. For example, I am taking the x of n as input, it is the bounded input, that is less than infinity. Then the response for the x of n is, I am taking y of n, this also I should get the bounded output. Okay, that should be less than infinity. Then the system is called a stable system. Otherwise, it is a unstable system. If the impulse response is absolutely subbable for a discrete time system, then the system is stable. For the impulse response, for the stable system, if we consider that is sigma n is equal minus infinity to infinity, mod h of n should be less than infinity. The impulse response, the summable impulse response should be less than infinity. Then the system is called a stable system. So the conditions for a system to be BBO stable are given below. If the system transfer function is rational function, the degree of the numerator must be no longer than the degree of the denominator. So the degree of the numerator must be less than the degree of the denominator. Then the system will be the stable system. The poles, if we go for the Z plane, so the poles of the system must lie in the left half of the S plane. The poles should be lie in the left half of the S plane. And for Z plane, the pole should be lie in the unit circle. The pole should lie in the unit circle in the Z plane, and for S plane, the pole should lie in the left half of the S plane. Then the system is the stable system. If the pole lies on the imaginary axis, it must be a single order one. Then that is no repeated poles must lie on the imaginary axis. If I have the poles on the imaginary axis, single order pole should be there. Otherwise, the system is unstable system. So here we discuss about the linear system, which should satisfy the superposition theorem. Superposition theorem. And time invariant are time variant systems. The response input is delayed by the k units should be equal to the output is delayed by the k units. Then the system is time invariant system. Otherwise, it is a time variant system. Static and dynamic systems. Static and dynamic system. Static system is a memory less system. That is, output depends on only present input values. Otherwise, that is a dynamic system. Causal and non-causal system. Here, causal system is the output depends on the present as input, present input plus past input values. It will not depend on the future input values. Otherwise, it is a non-causal system. And stable and unstable systems. Stable and unstable systems. Stable, for bounded input, we should get the bounded output. Sigma n is equal 0 to infinity mod. The impulse response should be less than infinity. The condition for stable system. And FIR and IAR system. If the impulse response in finite duration, that is FIR system. And if the impulse response in the infinite duration, that is IAR system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.